Hello, everybody. Thank you for joining today's webinar, Improving Visibility and Collaboration with Your Data Science Teams. Just wanted to do a quick intro for Expero and CurveNote. We do hope that you enjoyed today's presentation hosted by Graham Gansel from Expero and Rowan Cockett of CurveNote. Please let me know if you have any questions. With that, we'll go ahead and kick off today's webinar.
Thanks, Laura. So today we'll be talking about improving the visibility of your data science workflows using a couple of different technologies that we prefer through the lens of fraud detection, specifically retail-based fraud detection. Today, I will be one of your tour guides on this journey through this webinar. And with me, I have Rowan Cockett, as Lauren mentions, who is the co-founder and CEO of a company called CurveNote, which is actually the solution that we've been using recently to sort of build this visibility into our data science work. So the schedule for the day looks like this. I'm going to just set the stage here to kind of talk about what we are doing and why all these pieces fit together. And if you have any questions about any of this stuff, at the end, we'll open it up to Q&A. Feel free to type in questions to the Q&A box as we go along. If we don't get to you, feel free to shoot me an email. My contact info is in here somewhere. Okay, so let me begin by showing you what the workflow looks like in the fraud detection space. This is a common setting across various data science and machine learning efforts. So it's not just germane to fraud detection, but we wanted to specifically mention this piece, this fraud detection setting, because we have a set of tools here at Expero which can up-level the common workflows for fraud detection that are in practice in industry today. So what's happening here at the bottom of this slide is a production workflow. So that is, customers are buying things. And in this case today, we'll be showcasing a case study about a clothing retailer. So customers are purchasing clothing online through online transactions. And as they make those purchases in real time, the fraud detection system evaluates that transaction and determines whether or not to surface a flag, a highlight, to a fraud analyst, who would then, of course, go in, do a review on those highly important flagged transactions, just to determine whether or not to let that transaction pass through, as I'm sure many people on the webinar are already doing today. So importantly, behind the scenes, what's going on is a really complex set of technologies have to interact with various users, the fraud analysts, and the data science teams on the back end. And as that all happens, there is an orchestration conducted by various organizations, teams inside of the company. So that includes data science, it can include data engineering, it can include back-end engineering and DevOps. And what we see across industries, but especially in these real-time use cases like transactional fraud detection, is that there is a missing piece of the puzzle. When you're trying to upgrade your systems or change them in any way, let's say integrate a new data source, as we'll be talking about today, it is really kind of difficult to understand what the data scientists are doing and whether the changes that they're making are having any benefit on that fraud detection system. So again, today we're going to be talking about an online clothing retailer. And we're going to be talking about integrating a new data source into the fraud detection pipeline that operates in real time. And the really important point here is that while all of these systems are operational in real time, they're being upgraded like any other software product, right? And what we need to do, and what is uncommon in the data science space as compared to other engineering, is that there is a great deal of R&D that goes on, testing, experimentation, trials, to determine whether or not the efforts and the changes are actually successful or are unsuccessful. That communicating those findings, that is the crux of the data science operationalization. And we can see here, those data scientists actually typing in the code have to communicate to the product managers to be able to, so that the product managers can be able to say, yes, this is an acceptable change and we want to deploy this into production. And when that stage is complete, those product managers, let's say maybe quarterly or monthly, whatever the cycle is in the organization, have to communicate those results up the chain so that the business owners, the stakeholders, can understand whether or not their investment in those new data sources were actually worth it, and whether or not they should continue to invest in those types of efforts or shift that investment into another direction to up-level those fraud detection pipelines. So let me jump into how the system works on the back end. What we see here is a system. This is our recommended architecture for a system that includes explainable AI to keep humans in the loop, to ensure, and those humans, by the way, are fraud analysts in this case, to ensure that the system operates realistically. And it includes two different technology types. One is machine learning, and one is graph or network structured data analysis. And the way that this thing operates is by ingesting data from whatever source systems you already have in house. I can use your machine learning algorithms that you may already have. It definitely includes some sort of graph structured information that could be in the form of a graph database, or it could be an in-memory system. And it combines all of those fraud detection scores into one easy to understand highlight or flag that we surface to fraud analysts, sometimes called level one analysts, in a UI, and allows them to interact with that information in a way that showcases why that flag was being surfaced. And most importantly, as you see in the right-hand side of the slide here, we actually expose the mechanism for those fraud analysts to tell the system why it was correct or why it was incorrect. And that enables the system to upgrade. And those upgrades actually operate both in real time, like in automated retraining of the whole system, or through the dedicated involvement of a data science team. And we can see 2 points here on this diagram where it's absolutely critical to highlight the visibility into what's happening inside of that system, which we'll talk about momentarily. Before we jump into that, let me just show you what the UI looks like, so we're not just talking about an ephemeral theory. This is the front end that we would expose, a very simple front end that we would expose to those level one analysts, those level one fraud analysts. What you see on this UI is a recommendation from the workbench, the fraud detection workbench, which is the system we showed in the last slide. And as you can see in that second column, it actually works in conjunction with whatever fraud detection system you already have in place. So as the fraud reviewers go through these details, they can, of course, filter and sort based on the top flagged items. And then they can dive into the details of the transaction, as we're showing on the next slide, where they have the ability to visualize the details of a transaction. So we show a map here. We have a set of explanatory reasons, as you can see in the left-hand slide, why this transaction was highlighted as fraudulent. And then all of the connected information that is related to historical transactions that have been fraudulent and or normal, to help those fraud analysts understand why that system was making that decision. At the very top of this UI, what you see is that little button that says, do you accept this transaction? Do you reject the transaction? And that information is the feedback that is fed back into the system for the upgrade of that system. So let me just summarize real quick here what we're doing in this fraud detection workflow. Everything we just looked at there in those last few slides was just that very bottommost layer, the blue production pipeline you see at the bottom of the slide. Again, what's happening there is, as you just saw, there is data feeding a hybrid fraud detection system that feeds a UI that the fraud analysts rather, are looking at. And that is happening all the time in real time. what needs to happen behind the scenes, again, is that we need to ensure that fraud detection system is operating at peak efficiency, at peak accuracy. And we do that, of course, in many different ways. As fraudsters change their behavior and conduct fraud in different ways, we may find that we need to change our system, retrain our model, or potentially like integrate new data. And in fact, that is what we're going to showcase here in just a couple of slides, how we communicate the results of experimenting with integrating new data sources to decide whether or not those changes are beneficial for our company and, of course, for the company's bottom line. So with that, let me turn it over to Rowan to kind of show you how this all works behind the scenes.
Awesome. Thanks, Graham. So I'm Rowan from CurveNote, and we're working on this communication platform for data scientists that also integrates into some of these other business processes, such that you can see some of the information that Graham was talking about and really surface that up and make it more transparent in your organization. So I'm going to take a little bit of a different lens than what Graham was talking about that production system that is being exposed to the fraud analyst, and talk about what is happening behind the scenes to keep these business critical systems up to date. And again, as Graham was saying, they require these sort of constant changes as new fraud patterns emerge, or you're integrating new data sets, or responding to how that system is being used in production. And so this is continually updating. And to update these systems, you're often stepping outside of the production system. And what data scientists are generally using is a tool called Jupyter Notebooks and sort of the associated Python ecosystem, which is the leading data science platform. And there's a number of challenges inside of the sort of collaboration inside of this space, just internal to those teams in terms of discovering and sharing knowledge and version controlling the results of these sort of notebooks. So we're going to touch on that a little bit in the demo. But a lot of this is going to be talking about how are you sharing those insights? How are you communicating those insights with the product managers, the lead data scientists, and sort of up the chain of the organization, such that you can ask questions like, how much did those research updates that the team is maybe working on for a number of months, or how do those actually improve the accuracy of our system? And should we continue in investing in data sets that are potentially quite expensive? And how do those compare to the return on investment that we're making here? And so that's this sort of process of internal collaboration inside of the data science team. And then there's a process of remixing and aggregating those results and summarizing them and making sure those are all up to date, because this cadence has to happen fast and continually. And so it's often not appropriate to put large, brittle production systems in place in this more research and experimentation world. And so summarizing a little bit about why this technical collaboration is hard is there's often low visibility into that those data science processes. And it's due to the research and experimentation nature, and also how teams are reporting outside of how they're actually working today. And generally that's an ad hoc process using things like email or Teams or Slack. And you're taking screenshots and sending them to your product manager, who's on you daily or biweekly to say, okay, what have you done today? And because they're screenshots, they're not actually connected to the data or the models. And because it's ad hoc, there's no really way to organize that information and make sure that as the product manager is summarizing that and aggregating that information upwards in the organization, making sure that those are actually the right plots, the right information, the right decisions that are actually connected directly to the data that is being made. And so because a lot of times in organizations, there isn't good communication processes in place because we're straddling about 3 different ways of interacting with this: connecting to the production system, researching that information, and then passing and communicating and aggregating that information up to decision makers. It's very difficult to make those data-driven decisions. And so how the process sort of works today is you have your data science and researchers who are trying to implement new processes, integrate new data sets, and improve the model performance. And when they're asked for information, they're copying and pasting screenshots, and the product managers are aggregating these. A lot of times the product managers don't have access to dashboards because this, again, is sort of very high cadence changes that the data science teams are making. And then in communicating that information onwards, that's through PDFs, emails, presentations, and a lot of times that information isn't connected down into into the actual information and data and models that are in production. So CurveNote is trying to span these different personas and disciplines such that you can get information up to the decision makers that is linked all the way back down to where the data scientists are actually working, and the product managers are in the middle, remixing that information and reusing it and presenting it in a way that makes sense to decision makers. And so how we're doing that is we have a collaborative notebook plugin. And so inside of your data science environment, often there's a lot of infrastructure that's in place to make sure that that's connected to the correct data sources and is secure. CurveNote fits on top of the existing solution through an integration that provides an API into a collaborative reporting environment that the product manager can work in, that connects backwards and forwards through that API directly into the Jupyter system. And the collaborative reports then can be shared into these sort of connected reports that are being presented upwards in the organization. And so the idea here is to really try and improve that technical collaboration, increase the visibility into those that sort of cloud above that production system, that data science team, and create up-to-date reports that are connected directly to those data and models, and facilitate some communication and feedback between the various folks who are working on this. And then again, for those product managers, making it really simple to summarize, aggregate, such that executives and people who are operating the business can make those data-driven decisions. Okay, with that, I'm gonna jump into a little bit of a demo, unless Graham, you have anything to add?
No, please go ahead.
Perfect. Okay, so this is CurveNote.com. It's a cloud-based system that allows you to sort of aggregate this information. And this is a showcase of my personal projects, but I'm actually going to jump into a team right now. So this is the Expero team, which has some management around who can see what. And I'm actually going to jump into one of the projects, this fraud detection project case study that we've been working on with Expero. And this has a number of different parts. And I'll start at the use case side of things. So what I'm showing you now is the reporting environment that's directly inside of CurveNote. And so this is an interactive, collaborative writing environment that has some communication and commenting that I'll show in a little bit. But in terms of setting up the use case here, as Graham was saying, we have a retailer who is dealing with on the order of 80 million transactions every month. And they have invested a lot in their fraud capabilities over the last few years, and they are have these machine learning processes and systems in place to prevent 37 million in fraudulent transactions in the last few years. So they have an in-house team of data scientists and sort of a DevOps group that is helping integrate this all together. And so the case study here is to improve the model in production, and that requires training and selection and evaluation work, as well as reporting out to the product managers and up to the VPs and C-suite to actually show that there is a return on investment in this. And so there's quite a few of those reporting criteria that is required in this project. And so in this case, there's a new social data set that costs on the order of 15,000 a month. And the team has a quarter to demonstrate a 3 to 5% improvement in the model performance. And so I'm going to step forward in time. And so this project was a success, and the team made significant model improvements. And I'm going to show a little bit about, again, this communication processes internal to this team that involves the data scientists working together, reporting to the project managers, and then reporting upwards in the chain in terms of summarizing that information. And so I'm going to start with a report to the VP. So this is, again, a way to organize that information such that it's all together, all connected, and directly in line. And so a lot of what the executives are looking for here is those return on investment and making sure that we're actually getting what we want out of the models, as well as out of in terms of like cost benefit here. And so there's a number of reports that are interactive and included in for the VP, as well as a lot of different supporting data. And these are not screenshots directly. They're coming and connected directly into the CurveNote environment and supported by a graph of information that's actually connected directly into the data science Jupyter Notebook environment as well. And so I'm going to jump over into a report that the project manager is writing, and specifically a chart in terms of the model performance that has been improving over time as the data science team has been working on various approaches to including this new data set. And you can see here that the false positive rate is decreasing, and we've actually gone from about 12% down to 9% here. And so this is a chart that I want to show to my boss as a project manager to demonstrate that we've actually met the project goals. Is we have increased the model performance by 3% here, and we want to demonstrate this and show off the team. And so unfortunately, the data scientist here hasn't labeled their axes. This isn't in a presentable form. So I'm just going to ask the data scientist a quick question here. Can you improve it? And so this is showing a little bit of the collaboration environment that is directly integrated into CurveNote. And the difference, again, this is not a screenshot. This is actually an embedded plot that has some integrations directly into the Jupyter environment. And so I'm going to step over into Jupyter and show a little bit of the collaboration that's in the Jupyter environment. And so this is, if people are familiar with Jupyter, this is a Jupyter notebook. The only difference here is that there is an extension that CurveNote provides that allows some commenting and version control directly integrated into this experience. And again, this is to surface that information as well as provide collaboration for the data scientists internal to that team. And so this is the chart that we're working on. And this has all sorts of code. This is actually pulling from the production database where we have sort of an integrated environment here that Jupyter provides. And we've just got a notification that says, can you improve this plot? And just for the purposes of this demo, I'm also going to make this orange so it's very obvious what has actually changed here. And so we've labeled our product, our axes in terms of the percent improvements of the false positive rates going from 12 to down to 9.12, and talking about the various model runs. And there's a lot more analysis in all of these various notebooks. But what I'm going to do here is just save a new version of this. And so this is connecting to the CurveNote system through our API and allowing those changes to propagate such that the project manager, the person that I'm collaborating with, can actually use these results further in their reporting. So I'm just going to reply to that comment and jump back over to the reporting environment that we saw. And this doesn't update right away, but we do get a notification that there's a new version. So I can jump all the way to the latest version and actually pull that information in. And so I'm gonna actually go in and use this version in my further report. And so this is something that I, again, want to show upwards in the organization. And so I'm actually going to go into that and copy the latest version of this. And this is a reference to that. And I'm going to go and edit that, that report that I'm writing to my VP. So I'm just going to go and hit the edit button here. And instead of actually copying a screenshot into this, I'm going to import that directly. And so I'm just going to paste that reference to that block in, and there's integrated version control, integrated security and permissions management into that block specifically. And this means that this actually can go directly in this report, and I can show and ask those same questions, and that piece of information is directly connected into where that is actually being made. And so this, again, is aiming at improving visibility inside of the data science team, allowing that project manager to remix information, summarize it, and expose it upwards into a report that is actually accessible to other people in the business. And you can export that then into other forms and other places inside of your business. So that is a bit of a demo of what CurveNote is possible of, or can do today, is adding some of this collaboration, the version control inside of Jupyter Notebooks, and exposing that information upwards and outwards inside of your organization. So thank you very much. And I'm going to hand it back over to Graham.
Sure, I'll wrap it up. Thanks for the demo, Rowan. As you can see, this is the CurveNote system is really cool, and as I mentioned, we've been using it now exclusively for doing our data science visibility and communication. It's been really good for us, and I just wanted to kind of show what the delivery schedule or the implementation schedule looks like for a full fraud detection system here. What you should do is start using a system, a data science visibility system, immediately, because even if you don't have any infrastructure but tons of tooling in place, or even if you do, actually, you get the benefit of communication across data science and other teams immediately. If your teams are already, if you have data science teams that are already using some of the technologies that Rowan showed, it's just a no-brainer to start with that. The rest of the implementation roadmap really revolves around what you already have in place at your organization. It includes the sort of delivery-based pieces, which are, machine learning ops and the associated DevOps pieces to get those models in production. The next piece of the puzzle is to build a framework for doing some continuous releases, and as we showcased in the beginning of this presentation, enabling that system which automatically retrains itself and upgrades its accuracy. And the final piece of the puzzle, which is, sort of the holy grail, the promise of data science, is to be able to understand the rationale and the decision making of that system, which is, parts of which we showed earlier on in the presentation with that explainable AI stuff. So if you're interested in any of this stuff, feel free to reach out. We love to talk to folks about this, no matter what tech you already have in place. I'm going to turn it over to Laura now. I think we've had some questions come in, and hopefully we can answer some of those for you.
Yeah, thank you guys so much. We did have one come in for Rowan. We run our own internal data science infrastructure. Will CurveNote work with that?
Yeah, so CurveNote has sort of an extension that it puts on top of these data science pieces, which are, again, we're working specifically with Jupyter and have sort of a first-class experience there. And so nothing about your infrastructure needs to change. This is an extension that allows the data scientists to work collaboratively and pass that information over to the product managers, who again can sort of remix and reuse that. So it works with what you already have.
Great, thank you so much. We also had one for Graham that came through. How do I know if the fraud detection solution you talked about is right for my company?
Sure. Yeah. And again, feel free to reach out if you want to talk about specifics, but we can integrate with technologies that are already in place. So like, for instance, if you're already using Actimize or CyberSource or something like that, this system, as we showed in the beginning of the presentation, actually sits alongside those other systems and uses those systems information, the outputs from those things, as to benefit the hybrid system overall. If you have nothing in place at all, our system still works. What we do in that case is we ingest only the raw data sources, which are things like transaction information, all the information associated with web browsing behavior, all those things. So I guess the answer to the question is the solution is probably right for your company because it's very flexible, but feel free to holler if I can help anymore.
Thank you, Graham. There was another one for Rowan. We have archiving requirements on all of our reports. Can I get hard copy of our reports out?
Yeah, absolutely. So I think a lot of what CurveNote is trying to do is trying to bridge that gap between these sort of data science pieces and then the communication with the rest of the business. And so if there are requirements to get PDFs or Word docs out, we have export capabilities inside of CurveNote that allow you to get those reports where they need to be. And that's all automated, and it has an API behind the scenes that your developers or other folks can use.
Okay, thank you. And then it says, is it possible to interactively explore the data within the reports?
Yeah, so a lot of the pieces that the data scientists are generating are not static information. And I was showing a little bit of that inside of the reports in terms of these interactive graphics. And so those are actually have all the data embedded, and you can explore that information with some other tools. And so we're working on other ways to make sure that that is interactive and works for you guys.
Okay, super. Graham, there was another one for you. Can I use your fraud detection process if I already have a fraud detection system in place?
Sure. The pieces of the system you're probably interested in are the explainable AI pieces, maybe the human in the loop interaction stuff. Yes, indeed, those pieces do fit right in with any detection system you have in place because they are existing system agnostic. They interface with whatever tech is already in place there.
Great, thank you, Graham. And Rowan, there was one last one for you. I think you might have touched on this, but would we want to integrate this with some of our other systems? Is that possible?
Yeah, no, you're right. I think so absolutely we want to integrate with the various parts of the business that need this information. That's the entire goal of CurveNote, and so we have a full API behind what we were showing that enables that to happen, and so it can integrate pretty seamlessly.
Okay, thank you so much. That was it for all of the questions that came through. We will be sending out an email with the recording. So if you have any questions or want to follow up, feel free to reach out to us and I'll be happy to get a call set up. Otherwise, unless Graham or Rowan have anything else for today's presentation, we'll go ahead and end things.
Nope, thank you so much.
Thanks, everybody.
Yeah, thank you guys. Have a great day.
All right, bye-bye.